just darkness. And yet, inside that darkness, something was hiding. Thousands of worlds. Worlds no human had ever seen. Worlds that don't exist in our solar system. Worlds that shouldn't even exist, according to everything we thought we knew. And when scientists finally decoded the data, they didn't just find planets. They found possibilities. Planets with two suns. Planets covered in oceans of lava. And planets that might be more Earth-like than Earth itself. This is the story of the Kepler Space Telescope, and the moment it quietly changed our understanding of the universe forever. In 2009, NASA launched a mission that looked almost boring. No dramatic landings, no astronauts, no stunning close-up images of planets, just a telescope placed into space with one simple task: stare at the same patch of sky, not for hours, not for days, for years. Because hidden in that tiny region of the Milky Way were over 150,000 stars, and around many of those stars, something was orbiting. Something invisible. Something that didn't emit light, but revealed itself in a very subtle way. The method Kepler used was almost unbelievably precise. It didn't look for planets directly. Instead, it watched stars very carefully. And if a planet passed in front of its star, even for a moment, the brightness of that star would drop just a tiny bit. We're talking about changes so small, it's like noticing a single pixel dim on a massive screen. But Kepler could detect it. And not just once. It watched for repeating patterns. Dips in brightness that happened again, and again, and again. That's how it confirmed something extraordinary. There are planets everywhere. Over the next 9 years, Kepler didn't just find a few planets. It found thousands, more than 2,600 confirmed exoplanets, and thousands more candidates. Suddenly, our solar system didn't feel special anymore. It felt average, and that realization changed everything. Because for the first time in human history, we weren't just imagining other worlds, we were cataloging them. But here's where things got strange. Really strange. Because the planets Kepler discovered didn't look like ours. Some of them orbited so close to their stars. A single year lasted just a few days. Imagine a planet where one side is permanently facing the star, burning at temperatures hot enough to melt metal, while the other side is frozen in eternal darkness, a world split into fire and ice. No sunrise, no sunset. Just extremes. Then there were planets with not one, but two suns. Binary star systems. Imagine standing on the surface of such a world and watching two stars set on the horizon. A real-life double sunset. It sounds like science fiction. But Kepler proved it's real. These systems exist, and they are far more common than we ever expected. And then came the most important question of all. Are any of these planets like Earth? Not just in size, but in conditions. Because for life as we know it, one thing is essential: liquid water. And for liquid water to exist, a planet has to be in a very specific region around its star. Not too hot, not too cold. Just right. Scientists call it the Goldilocks zone. Kepler searched for planets in this exact region, and eventually, it found them. Earth-sized planets, orbiting at the right distance. One of the most fascinating discoveries was a planet known as Kepler 1a6e, located about 500 light-years away, roughly the same size as Earth, orbiting within the habitable zone of its star. And what made it even more interesting was the possibility that it had seasons, a stable climate, conditions that could support life. Then came another discovery, Kepler 1649c, a planet that shocked scientists. Because it wasn't just similar to Earth, it was almost identical in size, receiving about 75% of the sunlight Earth gets, meaning its temperature could be very similar to our own planet. For a moment, it felt like we had found a second Earth, But reality is always more complicated. Because being in the habitable zone doesn't guarantee life. Many of these planets orbit red dwarf stars, stars that are smaller, cooler, but far more violent. They emit powerful bursts of radiation. And that radiation could strip away atmospheres, destroying any chance for life to develop. So even if a planet looks perfect on paper, the reality might be far harsher. And yet, the numbers are impossible to ignore. Based on Kepler's data, scientists now estimate something incredible. 1 in 5 Sun-like stars could have an Earth-sized planet in the habitable zone. Think about that for a second. Our galaxy alone contains hundreds of billions of stars, which means there could be billions of Earth-like planets just in the Milky Way. But Kepler's discoveries weren't just about finding Earth-like worlds. In fact, some of its most fascinating discoveries were the strangest ones, like hot Jupiters, massive gas giants, orbiting extremely close to their stars, so close that their atmospheres are literally being blown away, turning them into glowing, evaporating worlds. Then there are super-Earths, planets larger than Earth, but smaller than Neptune. Some are rocky, some are covered in thick atmospheres. Some might even be ocean worlds, with global seas stretching across the entire planet. No continents, no land, just endless water. And perhaps the most mysterious of all are planets in multi-star systems, where gravity itself becomes unpredictable. Kepler discovered systems with 2, even 3 stars, and somehow, planets still manage to orbit them, balancing in a complex gravitational dance, stable, yet chaotic. These systems challenge everything we thought we knew about how planets form. But Kepler's mission wasn't infinite. After nearly a decade in space, it began to run out of fuel. And in October 2018, the mission came to an end. With a final command sent from Earth, the telescope was shut down. Quietly. No explosion. No dramatic ending. Just silence. From a machine that had spent years listening to the universe. But Kepler didn't really die, because the data it collected is still being analyzed today. Hidden inside that data are discoveries we haven't even made yet, planets that haven't been confirmed. And now, a new generation of telescopes is taking over, like the James Webb Space Telescope, designed to go even further, not just to find planets, but to analyze their atmospheres, to detect gases like oxygen, methane, water vapor, possible signs of life, real evidence, not speculation, but proof. For the first time in history, we are getting closer to answering a question that humanity has asked for thousands of years. Are we alone? And thanks to Kepler, we now know something extraordinary. The universe is not empty. It is filled with worlds. More than we ever imagined. Stranger than we ever predicted. And somewhere out there, one of them might be looking back at us.